Bismillahirrahmanirrahim. Today we are going to solve Cambridge IGCSE Physics Paper 2 Multiple Choice Extended for the session of October-November 2023. We have the subject code 0625 and the variant is 22. We have 45 minutes for this paper and we have to solve 40 MCQs. Also in the instruction that is written that take the weight of 1 kilogram to be 9.8 Newton and value of G should be 9.8 meter per second square. So we're going to start our paper from the question number 1. Question number 1 is the easy. What is the scalar quantity? We know that scalar quantities are those quantities that are defined completely by their magnitude. So we know that acceleration is a vector quantity, force is also required a direction. That's why force is a vector quantity and time is the scalar quantity because time doesn't require direction, and velocity as well is a vector quantity. Moving to question number 2. Question number 2 is that a student measure the average speed of a cyclist in a race. Which quantity must she measure? Option A. We know that the average speed has a formula of total distance divided by total time. Option A. The total time taken to complete the race and the time taken for the cyclist to reach at the highest speed. No. To reach at the highest speed, this is the wrong option. The time taken to this is also the total distance traveled by the cyclist at her highest speed. At her highest speed, this is wrong. The total time taken to complete the race and the total distance traveled by the cyclist. Yes, these are the two quantities that are required because every distance has a formula of total distance divided by total time. So option C is carrying both these two parameters, so that's why option C is the right option. Moving to question number 3. We know that moving to question number 3, the diagram shows images of a moving object taken at regular interval. The object is moving from left to right. We can see that from here the object distances are almost same, and after some interval the distance start increasing. Okay, this statement describes the motion of the objects. The object accelerate continuously. No, because at start this object was not accelerating, object was moving with a constant speed. The object decelerates. No, this is also the wrong. The object varies at constant speed. The object travels at constant speed. Yes, at start object was traveling with the constant speed and then accelerate. Yes, because each time the distance is increasing, it means that its acceleration is increasing. So option number C is the right option for question number 3. Moving to question number 4. A plastic ball has a mass of 4 kg and a volume of 20 centimeter cube. There is a crack in the ball surface. Like if you have the ball and it is in that portion, if the ball has some sort of crack, obviously the ball is placed in the bath of water leaks into the ball. When the ball has a crack, the water will pour into it without changing the volume. This is the important information. We don't need to change the volume. Ball eventually ball sink. The density of the water is also given, that is 1 gram per centimeter cube. Which mass of water has entered the ball? Then the top of the ball is first level with the water surface. We need to find the amount of water that has entered into the surface, into the ball after the crack. We know that density has a formula of mass over volume. So we can calculate the density easily because we have been provided with the mass as well volume. Mass is 4 and the volume is 20. So 4 by 20, it would be 0.2 gram per centimeter cube. So this was the density. Now we know that both have the same density. Density of the water and density of the ball is same, and density of the water is equal to 1, but we don't know the mass that have entered into the water into the ball, so that's why we will take m by 20. Why we are taking 20? Because in the question it is mentioned that the volume of the ball is same. So this is how we're gonna get m is equal to 20 grams. So this is the new mass. So after 20 mass, and initially the ball has a mass of 4 gram, you're gonna subtract it, 20 minus 4, you would get the new mass that has entered into the ball. So the water mass would be equal to that would be 16 grams. So option number B is the correct option over here. Moving to question number 5. Question number 5 is that a satellite orbits the Earth at the constant speed in a circular orbit. Which statement is correct? The resultant force on the satellite is 0. The resultant force, because we know that when the object is moving in the circle, its direction is always towards the center, and when the satellite is moving, it means that the center should be at the Earth. So option number B is showing that option, the resultant force on the satellite is towards the Earth, and option C is the wrong option because it's telling it is moving away from the Earth. No, object moving in the circular path has always direction towards the center of the point, and the satellite has the center towards the Earth. So option number B is the correct option. Moving to question number 6. Question number 6 is that the diagram shows 4 identical objects. Each object is acted on by the forces shown. Which diagram shows the object is in equilibrium? We know that it is 10 Newton, 20 Newton and 20 Newton downward, but it is acting at one end. So this is the wrong option. 10 Newton and 20, it should be placed 20 Newton here to balance it, but it is written 10 Newton, so this is also the wrong option. Moving to option number C, we can say that object is 10 pulling towards 10 Newton, pulling towards left is 10 Newton as well, but object should be 10 Newton towards the downwards to be the resultant force should be 0. So option C is also incorrect. Now option D has the upside force 20 Newton and the downward force are also 20 Newton, and this object is carrying at the 20 Newton at the center. So option number D is the right option. So this was an easy and simple question of the resultant forces. Moving to question number 7. Question number 7 also belongs to the resultant force. Question number 7 is that a resultant force accelerate a car of mass along a straight horizontal road from rest to a speed v in time t, giving it momentum p. Which pair of relationship this situation is correct? Okay, first we know that momentum has a formula of mass into velocity, and we know that force is equal to rate of change of momentum, and when we need to cross it, F cross t is equal to momentum or change in momentum. So we're gonna look that which option is a better option here. Is the correct. Ft is equal to p and p is equal to mv. So this is the right option. So option number C is the correct option from our calculations. Okay, this was also an easy question. Moving to question number 8. Question number 8 is a roller coaster ride. The diagram shows a part of the roller coaster ride with the car at different position. The car runs freely down from position X to position Y and up to the hill on the other side. It means that it is moving from here to here. Okay. What happens to the energy in the kinetic and the gravitational potential stored of the car as it moves from the position X to Y? We need to find what energy changes take place over here from X to position X to Y. We know that at position X it has stored the kinetic, and its kinetic energy will start to increase when it is moving here because velocity would increase, but it decreases height, so its potential energy would continues to lower. So its kinetic energy would increase and potential energy would decrease. So option number C is the right option from the given option. Moving to question number 9. A box is initially at the rest of a top rough slope. Okay, now you can see the diagram as well. The box slides down the slope. The weight of the box is 20 Newton. The slope is 4 meter long and 2 meter high. The box does 10 joule work against the friction as it slide down the force. Okay. What is the speed of the box as it reaches to the bottom of the slope? So first we need to find the energy for it. Object is moving, so if we have to find kinetic energy, 1/2 mv square. This is the formula for the kinetic energy, and we know that delta E is the work done equal to work done, and gravitational potential energy would be equal to kinetic energy plus work done. So this is our basic equation. We need to put our values over here. mgh is equal to 1/2 mv square, and we know that the work done was given, that was 10 joules, so we're gonna put this value 10 over here. Okay, we need to find the value of V because that is what we have required. We know the value of mg has a value of 20 Newton because the weight was carrying 20 Newton. So this was a bit tricky question, so we have to put 20 over here. And the height is, from the diagram we can see the height is 2, substituting over here 1/2. And what would be the mass? We can get the mass by W by G. We know that W is 20 and G value is 9.8, so we're gonna write over here 20 by 9.8, and we have to find V square plus 10. Okay, so this would be 40, then 40 multiplied by 2. Okay, first this would be 40 and 2 gonna cancel with 10. It would be 10 V square over 9.8 plus 10. You're gonna subtract 10 from the 40. This would be 30 is equal to and 10 V square over 9.8. Then you have to multiply 30 by 9.8 and divide by 10, and taking the square root of this value you would get the answer, that is equal to 5.42 meter per second, and we have option A over there. So that was carrying the lot of calculation for this part, but this was an easy question, but you need to put the data very carefully, and this was the important thing which you have to build the equation yourself. Okay, now moving to question number 10. Question number 10 is also some sort of calculation. An electric car is charged overnight in 8 hours. Time is given, 180 megajoule of energy is transferred. What is the power of the charger? We know that the formula for the power is P is equal to E cross T, and energy is given, that is in the form of megajoule. We're gonna convert it into 10 raised to power 6 into simple joule, and also the time is given in 8 hours. You're gonna need to change it into seconds, so you have to multiply it by 3600. After solving it, you would get the value of 6300 watt. That would be equal to 6.3 kilowatt. Okay, there was some formula should be like that. P is equal to W by T. You need to divide it, not multiply. So 180 into 10 raised to power 6 divide by 8 into 3600. So you're gonna get 6.3 kilowatt or 6300. So option number A is the correct option. Moving to question number 11. An object, okay, an object is a depth h below the surface of the liquid. The pressure due to the liquid at this depth is rho. The gravitation field strength is, what is the density of the G? So we know that pressure has a formula rho G H, and if we gonna separate or make density as a subject, then it would be pressure over GH. So option number D is the right option over here. Moving to question number 12. Question number 12 is Brownian motion is the random motion of particles. In which state of matter the Brownian motion is observed? Okay, gas, liquids and solids. No, solid and particles are two closest, gases and liquids only. So option number B is the right option. Moving to question number 13. The volume of a fixed mass of a gas is varied. The temperature remains constant. Which graph shows how the pressure P of the gas vary with the volume V? We know that pressure and volume has an inverse relation, 1 over V. Okay, so pressure is inversely proportional. When we increase the pressure, this is Boyle's law, the volume decreases, and the graph is between pressure, and this means pressure doesn't change. This is wrong. This means that pressure and volume is directly proportional. This is also wrong. This 1 over V, when we plot the graph between pressure and 1 over V, it should be straight line. So option number D is the right option. Moving to question number 14. Question number 14 states that liquid evaporates from a beaker. What happens to the temperature of the remaining liquid, and how does this temperature changes affect the rate of evaporation? We know that temperature decreases and the rate of evaporation also decreases when liquid evaporates from the beaker, because high energy particle left, and so that's why temperature decreases and the rate of evaporation also decreases. So option number A is the right option. Moving to question number 15. The thermal energy delta E is supplied of an object of mass m which does not change in state during the heating process. The temperature of the object rises by delta T. What is the specific heat capacity? Again, this is a testing of our formulas, and we know that delta Q or delta E is equal to MC delta T, and this is we're gonna get C from here, delta E over M delta T. So option number A is the right answer over here. Moving to question number 16. Okay, question number 16. A room is heated by a radiator. The diagram X and Y show two possible circulation of hot air with which heat the room. When we know that when hot particles goes up because their density decreases, so we have to select which diagram and explain the heating process of the room or by convection. For convection, the hot particles should from radiator goes upside, so we can say that the diagram X show that the particles after getting heated up goes upside down and move towards it. So option number A, air density increases when air is heated, because particle expands, their volume increases. Okay, so option number A is the right option. Moving to question number 17. Our student writes down some facts about the two transverse wave. Wave 1 has a frequency f, okay, and a velocity v. Wave 2 has 4 times the frequency of wave 1 and it is traveling with the velocity 2v. What is the wavelength? We know that formula is V is equal to F lambda, and if we have to calculate the wavelength, that formula would be velocity over frequency, and the value of velocity is equal to 2V, and the frequency has a 4 times, so value of frequency is 4F. So after solving it, we're gonna get V over 2F. So option number D is the right option from these calculations. Okay, moving to question number 18. State wavefront on the surface. Wavefronts are those that have the same same phase. Okay, on the surface of the ripple tank approach a gap in a barrier. The diagram shows how the wavefronts change the shape as they pass through the gap. What is the name of this effect? We know that when there is some disturbance, this is the diffraction. Light travels. Moving to question number 19. Light travels from air into the glass. What is the relationship between refractive index of the glass and the angle of incidence I? And again, this is the formula, n is equal to sine I over sine R. So option number C is the right answer. Moving to question number 20. The diagram shows the image correctly by the reflection from the mirror. Object and image should be at the distance. Here the distance is increased, so this is the wrong option. Here the distance is exactly the same, so option D is the correct option. Here the object is wrong, and it's also the wrong option. Moving to question number 20. Question number 20 is from the topic of lens. Question number 21. Okay, 21 is from the topic of lenses. A student passes parallel rays of light through 4 different converging lenses. He measured the distance x and the distance y is varied. Which lens has the longest focal length? We know that when object passes through the mirror, after passing through the mirror, if the line is parallel to principal axis, it should pass to the focus point. So this would be the our focus point. So x value does not relate to the value of y. So highest focal length would be from the given option is 3.1. So option number B is the right option. This was a logical question. Moving to question number 22. The frequency of the microwave used in a microwave oven is 24 megahertz. What is the wavelength of this frequency? We know that formula for the lambda is equal to V by F, and for electromagnetic wave we use the speed of light, that is equal to 3 into 10 to the power 8. Also the frequency is given, that is in the form of megawatt. We're gonna convert into 10 to the power 6. After solving it, our answer will be 0.125 meters. So option number A is the right option over here. Moving to question number 23. Okay, which rows gives the typical values of the speed of the sound in solid and in gases? Again, this is a simple question. We know that speed of the sound is greatest in the solid, and in the gases we know its values are close to the 300 meter per second. So option number D is the right option over here. Moving to question number 24. 24 is that hard magnetic material can be used to make permanent magnet. Yes, and a soft magnet can be used to make a temporary magnet. Which row describe whether iron and steel are the hard or the soft magnet? Okay, we know that iron is a soft magnet and steel is a hard magnet, so option number C is the right option. Moving to question number 25. A power source is connected to a resistor XY. In which directions are the conventional current and the flow of the free electrons through the resistor? Okay, for the conventional current, it moves from higher potential to lower potential, so option number Y to X. And for the electric current, it should be from negative to positive, it would be X to Y. So option number C is the correct option from these options. Moving to question number 26. Question number 26 is that what is the unit of electromotive force? We know that electromotive force has a unit of voltage. This is the simple knowledge testing. Moving to question number 27. 27 shows that the graph of shows the current voltage characteristic of a filament lamp. This statement describes how the resistance of the lamp changes as the voltage increases. We know that when the temperature increases, the resistance also increases. So option number C is the right option for the question number 27. Moving to question number 28. In the diagram, rod R is suspended from an insulating thread. When the positively charged rod Q is brought close to the rod R, and rod R moves away from the rod Q. What conclusion can be made from this observation? Okay, rod R is charged, but it should be oppositely charged, because that's why they are repelling. So we can say that rod R must be positively charged. So option number B is the right option, because over here it was written it is moving away, so it means it is repelling. So we know that like charge repel each other, that's why it was moving away. Moving to question number 29. 29 is the circuit diagram shows, wait a minute, 29 shows the circuit diagram shows a circuit to be used as AC, to be run in a DC motor from an AC supply. Okay, but graph shows the current in the motor. Okay, so it is a DC motor. We know that for the DC motor, and this could not be possible, and the current is not changing here, so it would not be possible. So because in supply was AC, the current should be continuous, current is constant. This is also the wrong option. Only option left correct is the D option. Moving to question number 30. Question number 30 is that the circuit diagram shown can be completed by inserting components at X and Y. Okay, the completed circuit is a potential divider in which the potential difference across component Y increases when the temperature increases. Which row show the component of X and Y? Okay, we know that for the thermistor, when the temperature increases, the resistance decreases. So option number D is the right option, because when the temperature increases, resistance decreases for the thermistor option. Moving to question number 31. Okay, question number 31 is the application of Lenz's law. Lenz's law is that whatever changes the current produces, the induced current, it would oppose it in a way that it would not produce. Okay, so if it is south and it's north, we also have to apply the right hand rule for this question, like that and like that. Okay, the north pole of a bar magnet is pulled away from it is moving away from an X, which causes an induced current in the coil. The magnet is now turned round, so that north pole is on the left side. Okay, it is taken to the other end of the soft iron, and the north pole is pushed towards the end Y. Okay, a new current is induced in the coil. Which statement is correct? The new induced current is in the same direction, causes the soft iron to repel because it opposes the change. So option number D is the right option, because it opposes the change. The new induced current is in the opposite direction, that's why it is the wrong option. The new induced current, this is also the new induced current is in the same direction, causing the soft iron to attract. No, it could not cause the attraction, because Lenz's law state that it opposes the change which induces the current. So option number D was the correct option. Moving to question number 32. The diagram shows a wire in the magnetic field between two poles of the magnet north south. Okay, over here we have to use Fleming left hand rule, like that. Okay, the current in the wire repeatedly changes between changes between a constant value in one direction and constant value in the opposite direction as shown in the graph. What is the effect of the wire? The force on the wire alternates between one direction and the opposite direction. Okay, this is the right option. The force on the wire alternates between one direction and the opposite direction. So this is the right option for the question number 32. Moving to question number 33. A transformer has NP turns on its primary coil and NS turns on the secondary coil. The voltage across the primary coil is Vp and the voltage across the secondary coil is Vs. What is the relationship between these four quantities? Okay, this is a simple, again the testing of formula. Vp over Vs is equal to Np over Ns. So again this you just need to memorize the formula. Moving to question number 34. A magnesium ion has a double positive charge and chloride ion has a single negative charge. Which statement is correct? Okay, a chlorine atom gains an electron to form a chloride ion. This is the right option. This is more of a chemistry question. Okay, which road correctly describes an example of radioactive decay? We know that for the radioactive decay, decay happens due to the unstable nucleotide. So these are the correct option, and emission of all three particles would be possible: alpha, beta, gamma. Okay, so anything could be from these three options. Obviously element changes, that's the option number B is the right answer, because change of element happens when the radioactive decay happens. Okay, moving to question number 36. A radioactive isotope of sodium has a half-life of 15 hours. The table gives the data from an experiment to show how the rate of decay of the isotope vary with the time. The background count rate has not been subtracted from these data. Okay, we know that background has not been subtracted. Okay, this is what is the background radiation count rate? Okay, we have to apply I think the shortcut way would be calculating the background count would be going by the reverse calculation method. If we check, this is the background radiation, and if we have to subtract 400 from 12, it should be 12 plus 388. After first half-life, 388 should be 194, and the after second half-life it should be 97, and after adding the background radiation 97 plus 12 it should be 109. So option number A is the wrong option, because our answer should be 115. Moving to is B option. B option is like that: 15, we have to add 15 plus 385, and taking the half of 385 it would be 192.5, and again taking its half it would be 96.25. adding 15 in it, we're gonna get 111.25. this is the wrong option. Moving to the C part. C part is that 20, so we have to add 20 plus 380 to make it to 400. Then taking half of it, it would be 190. Then taking half of 190, it would be 95, and adding the background count of 20, we would get 115. This is the right option. This is how we have calculated through back calculation. So option number C is the right answer. Moving to question number 37. What happens in the process of nuclear fission? Okay. We know that nuclear fission atom splits up, so the nucleus of unstable nucleus splits up. So option number C is the right option. Moving to question number 38. 38 is that the time taken for the earth to orbit the sun is approximately 365 days. Okay, now you can see the question exactly. The average radius of the earth orbit around the sun is 1.5 into 10 raised to power 8 kilometer. What is the average orbital speed of the earth? You need to calculate the average orbital speed. We know that the formula for the speed is distance over time, and distance is covered by the circumference of the circuit, that will be 2 pi r over t. We know the value of 2 pi, and we can calculate the radius, that is given 1.5 into 10 raised to power 8 kilometer. It is should be converted into meter. All our answers are in the form of meter per second, that's why we are converting. Time is 365 days, you need to convert into the seconds, so multiplying 365 by 24 into 60 into 60. After solving it, you're gonna get the value that is equal to 3 into 10 raised to power 4 meter per second. So option number C is the right option over here. Moving to question number 39, the transfer energy to the earth through the electromagnetic radiation. What are the two of the parts of electromagnetic spectrum to which most of the energy belongs? Gamma rays and X-rays. Okay. Infrared radiation and visible. We know that for the sun it always carry infrared radiation and visible, right? So option number B is the right option. Moving to the last MCQs. How does the sun produce energy? Sun produce energy by the fusion of hydrogen, not the fission of hydrogen, only by the fusion of hydrogen. So option number D is the right option. Hopefully you get the understanding of this paper, and if you still have queries related to some question, you can ask in the comment section. Do like the channel and subscribe it, and share it with your fellow friends. Thank you for watching it. Allah Hafiz.